VR Unity and Unreal Project Development Course. Video 7. Terrain Creation in Unreal. Welcome to JMPVR, my YouTube channel. It is a pleasure for me to be here again today, with all of you. Your invaluable help is very important, so that we can continue developing support videos for new independent developers. Please, do not forget to subscribe to our channel, and support us on Patreon. Okay, let's start by reviewing some basic concepts. Whatever VR project we want to develop, it inexorably needs an environment in which to develop our action. This environment can range from a simple room, to a large area. The object of today's video is to analyze, and create a terrain in the easiest, and most realistic way possible. Both, Unity and Unreal, have tools to generate terrain. However, neither Unity nor Unreal are appropriate applications for the generation of a realistic terrain, and require a very high artistic skill to achieve good results. Unreal, as we will see, has greater power when it comes to generating terrain. However, the generation process is more complex than in Unity. On the other hand, both in Unity and Unreal, we can use the terrain generation tools to edit a terrain generated by an external application to these VR engines. Then the first conclusion that we obtain is that we must generate our terrain with a specific terrain generation application, and later, once imported into Unity or Unreal, proceed to edit it if necessary with his own tools. Undoubtedly, at least today, Google Earth, due to the stability and quality of the altimetry data, is one of the best tools for obtaining digital terrain. Another important point is to obtain a suitable location for our VR project. For example, if our VR game takes place in a city, we must select a location area corresponding to a city in Google Earth. If on the other side, our VR game is developed in a forest, we must locate in Google Earth an area with characteristics similar to those desired. Let's talk about the process that we are going to follow through the next workflow diagram. Let's see the steps we are going to follow to obtain our land. First, we will select a location in Google Earth. Once the desired location is obtained, we open that location in Blender GIS. If you don't have the add-on installed, you can get it from GitHub. After that, we import the altimetry data into Blender. Next, we apply the necessary modifications to the terrain model obtained, in order to be able to implement our urbanization area, where our VR game takes place, such as platforms, high roads, paths, etc. Once the final model is obtained, we will generate a height map. As last step, once this process is finished, we will open our project in Unreal, and we will import our terrain model through height map. Well, once explained the process of obtaining our land, we are going to develop it, step by step, so that you can follow it, in a clear and simple way. Well, as we have explained in the previous section, we need to search for a location in Google Earth, according to the purpose of our VR game. In our case, our VR game The Ramson House needs exteriors corresponding to a mountainous area, of medium altitude, since our mansion is located near a road, in the middle of a forest. Once we have established the type of location we want to use, we search for it in Google Earth. In our case, we have located it in Spain, near the municipality of San Lorenzo de El Escorial. And within that municipality, we have chosen the mountainous area adjacent to said municipality. So let's get started. We open Google Earth, and look for the selected zone. On the selected zone is located, we make a screenshot, and save the file in image format. This image will serve us exclusively as a reference image. First, we check that we have the Blender GIS add-on installed in Blender. Remember, If you don't have it, download it on GitHub, and install it in Blender. To do this, we open Blender, and we select Edit, and then we select the option Preferences. Next, in the new pop-up screen, we select Install. We look for the file downloaded, in zip format from the add-on, and select it. Next, the add-on 3D view, Blender JIS, will appear in the add-ons list of Blender, and we make sure that the corresponding box is checked. We open Blender and we select the option JIS. In the new drop-down window that appears, we select the option Web Geodata. A new menu will appear next, in which we will select the option Base Map. We leave the default options that Blender JIS offers us, and we select OK. As we see on the screen, a world map of Google Earth appears. We press the letter G and a new screen appears, in which we can enter the municipality of the desired location. Next, we navigate through the area until we get an image similar to the one previously obtained in Google Earth. Once the image of the desired area has been adjusted on our screen, we press the letter E. Blender will cut out the external image that we can see on the screen, obtaining a cutout of the Google Earth digital model. We can check now, by navigating on the terrain obtained, that our terrain model is flat, and does not have any altimetry at the moment. The time has come, in order to incorporate the altimetry data into our digital terrain model. To do this, let's select again the JIS option, and the Web Geodata option. This time, in the new drop-down window, we select the option Get Elevation, SRTM, and we leave the options that Blender JIS offers us by default. Next, we press OK. After a few minutes, we will observe that our digital terrain model has acquired the altimetry data. We select our digital terrain model, and we select Apply Transform to each of the modifiers of our model, and we adjust the size and vertical scale to suit our needs. Now, we have a digital mesh of a real terrain of our desired localization. The time has come, in order to incorporate our platforms into the digital terrain model previously obtained. In our case, we will need an excavation platform in order to accommodate the basement of the mansion, a platform for the interior urbanization of the mansion plot, and the platforms of the surrounding roads, and finally the platform of the access road to our mansion. So, we proceed to place the platforms models in Blender over our digital terrain model. Once the two models are located, we proceed to edit vertex, edges and faces of the two models, until we obtain the combined digital model. Well, keep in mind an important fact, that it is the dimensions of our final terrain model. The dimensions in our case, of the digital model are 2000 meters wide, 2000 meters long and 264 meters high. We will need these values later. Now we proceed to export our model in STL format. In this way, any error of duplication of vertices in the mesh of our model, it will be eliminated. And we proceed to import the generated file in STL format, into a new Blender file. Well, now we select our camera, and we proceed to place it orthogonally position over our terrain, eliminating any type of rotation. Next, we proceed to scale our terrain until it appears in the plan view, included within the field of view of the camera. Remember that all the points of the mesh, Z value, must be above the 0 level. Once our new model is scaled, we obtain new dimensions of 7.18 meters wide, 7.18 meters long and 0.974 meters high. This last value will allow us to place the camera at a height of approximately 4 times this value. Finally, we will make sure that the type of camera selected is orthographic. Now, we select the option Shading in Blender. We select our model object and we select the option Plan View Z. Now, we create 5 nodes by selecting the Add option. The first node is a geometry type node. The second node is of the separate XYZ type. The third node is of the color and type. The fourth node is of the emission type. And finally, the fifth node is of type material output, and we connect them together as shown on the screen. Next, we select the option Render Properties in Blender, and we will change the render engine to cycles. Next, we select the option Output Properties in Blender, and we modify the resolution in X, and the resolution in Y, with the equivalence of 1 pixel equal to 1 meter. As our real terrain model has dimensions of 2000 meters wide, and 2000 meters long, we will put the value of these dimensions in both boxes. Finally, we will make sure that the color option is set to black and white and that the value of the color depth option is 16. Once these final adjustments are finished, we will select Render in the main menu of Blender, and in the drop-down menu, we will select the option Render Image. Once the render process is finished, we select the option Image, and then the option Save, and we will save our generated image. With this process, we finished obtaining the height map in Blender of our digital terrain model. Now is the time to open our Unreal VR engine, and import the height map file of our digital terrain model. To achieve this goal, we select the option Modes in Unreal. And next, in the pop-up window, we select the option Landscape. In the Landscape Properties window, we select the option Import from File, and then we select our height map file, generated in Blender. Once the rest of the parameters have been checked, we select the Import option. And now, we can see, our digital terrain model appears perfectly defined. Amazing! In future videos we will explain how to correctly apply realistic textures to our terrain model in Unreal. As you will have observed, the process of obtaining a realistic terrain from a selected location, and its implementation in Unreal, it is very simple, although it involves a longer process of obtaining the model than in Unity. I advise you to practice this method until you have mastered it completely. And so far, the 7th video of the VR Unity and Unreal project development course. Do not forget to subscribe to our channel, and support us on Patreon, so that we can continue to help you, by providing you with the necessary knowledge for the development of your VR game. I hope this video has been to your liking. I wait for you in the next video of the course. Thank you for your support and attention. Goodbye.